This video is about my implementation of Ason and Agrawal research on keyboard acoustic emanations. I expect that you have already read the abstract of the research, so let's get practical. The first requirement for the attack is to hold a recording of the victim typing. Here is an example. Let's have a look at it. Okay, let's play it. Okay, so we want to know what the victim has been typing. What we need to know is the model of the keyboard that the victim is using. Of course, this is just a demo, so it is myself. And I've already recorded what is necessary. Let's go into training. What I recorded is a Dell keyboard and a Trust keyboard, just for the sake of comparison. Well, you see here there are the recordings for every key of the keyboard. Let's have a look at one. I recorded 120 samples for each key, and that takes about 35 minutes. Okay, so now let's have a look at the workflow of the project. What we need are three things. We need training clicks. Here is a subset in the picture. So as I said, 120 clicks for each key in the keyboard. Then we need sample clicks. I used 20 for each click. And then we need a recording of the victim typing. Well, now from these recording, what I do is I extract each click, and you see here what a click looks like. We have a push pick and a release pick. The push pick is what we are interested into, since following Ason and Agrawal research, basically is what carries most information. So we extract it, and I apply a fast Fourier transform, which gives me the feature of the click. With such feature, I train a neural network using MATLAB, and I evaluate the performance of the network by asking the network to recognize a set of sample clicks. The procedure for the sample clicks is the same. From the recording, I extract each click. From each click, I extract the features, and I ask the network, tell me, given these features, what type of key this is. So, if this step is satisfying, I then apply this procedure to the victim's recording. So I have to determine, I must determine the beginning of each click in the victim's recording. Then I'm able to extract them, extract the feature, feed the feature to the network, and if everything is working, we've got a keylogger of, let's say, new generation, since it's non-invasive is neither software or hardware. Okay, let's have a look at it in MATLAB. Well, the first thing is this file called config. Here there are some variables that you might need to set. Here is the path to the training clicks, namely this folder. You see, Dell, recording Dell, and then the path to the samples and the path to the victim's recording. Here we specify how many clicks of the keyboard we want to use. For this sample, I use just the alphabet, and then you don't need to worry about those parameters. This is, let's say, advanced configuration. Well, here's the main file. Let's run it. Now it's extracting the clicks. It's loading everything in memory. Okay, this is done. Nearly. Z, okay. So here we have all the parameters. And now what we do, we train the neural network with the features. Here you see that I set the number of hidden layer size, the number of hidden neurons to 100. It is an open question how to find this number because it's problem dependent. However, let's keep it for 100. Okay, let's run it. We wait for the network to do the training. Good. Now we need a bit of user interaction. You see here, we need to determine a threshold in order to recognize the beginning of each click. The theory is described in the report, but you don't need it at this stage. So we see that we have 1, 2, 3, 4, 5, 6, 7, 8 clicks that the victim typed, and we don't need these low peaks, so we need to set a threshold that is good enough, and I would say 40. So you see, enter 1 to confirm or enter a new threshold. Let's try with 40. Okay, 40 seems good. We don't have those peaks as recognized. Now confirm it. 1. Cool. And then let's run it. You see, the first line is what the neural network guessed, and the second line is the second choice for each keys. You see that PSSWOR, well, what I typed was password, so of course it's not 100%. This is more of a proof of concept, but still, if you're trying to guess a password, this is quite a good hint. So that's all. Thank you for your attention.